My name is Kainton the Genius, and today we are going to perform one-way ANOVA step by step. Now, one-way ANOVA means analysis of variance, and we are trying to compare three groups. So in these particular examples, we have three groups of students, and we are trying to find out the effect of sound or music or playing a sound in the background while studying. For the first group, we have a group of students that we are studying with constant sound played in the background. The second group played a random sound in the background, and the third group played no sound in the background. So we want to see the effect of sound in the way they study. So we are going to perform this one-way ANOVA using Excel. I'm going to show you how to create all the formulas you need to perform this. So the first thing you want to do, I'm going to take out this because I've transferred the data to Excel. So the first thing you want to do is to shift this data this way and also shift this one away a bit so that we have some room. So in this cell, I'm just going to write it, I'm going to say squared. Let me just write it as cube because I can't really write to raise to the power in that place. So what it means, we are going to square x1. So I'm going to just say equal to, okay, let me use a function. The function is to square a number, just say POW, or just say power, and just use this cell. This cell here is B3, so I'm going to write power B3. So that is going to give us power B3. So it's asking us the power is going to be 2, so it's going to be raised to the power 2. Another option is to say B3 times B3 is going to give you the answer as well. So after calculating it, just drag it down as well. So also do the same thing in this place, power, and in this case we are saying power D3 to the power of 2. After doing that, just drag it down. And in this case, we are going to say power, and in this case, we are going to say F3, and we are going to drag it down as well. All right, good. So at this point, we've taken the powers, we've squared everything. So permit me to just put this and close this in some kind of put borders around it. Okay, fine. So now one thing I can do is to find the mean, and I also find, so let me find the mean here. Okay, so the mean is simply average. So say equal to average, and just select everything here, and just close the bracket, and that gives you the average. You can just copy this cell and just paste it here. So remember, we are taking the mean of the items and not the mean of the squares. Also copy this and then paste it here as well. All right, so now we have all the means. We want to now calculate the sum of the squares, right? Good. So we are going to calculate, first we are going to calculate this sum. So I'm going to say sum, and I'm going to say sum of squares. So let me call this sum. So this is a sum of everything, sum for x1. So I'm going to say equal to sum, and I'm going to just select everything here. Don't select the mean, as just select only the items A. So I'm going to also copy this one and just paste it here, and I'm going to copy it again, and I'm going to paste it right here. So now what we have here now is the sum of the squares, right? So I hope everything is fine. So I'm now going to calculate, what we have here is the sum, and now I'm going to calculate sum of squares. So in this case, I'm going to, so what I have here is the sum. So sum of squares is going to be in this column. So somehow I'm going to just, okay, I'm going to call it SOS, and I'm going to calculate it right here in this column. So in this case, I'm going to calculate the the sum of the squares. Okay, so sum of the squares, I'm simply going to say equal to SUM. So in this case, we are taking sum of the squares here. Okay, so also just copy and paste across. Just copy this and paste it right here. Just copy it again and paste it right here. And finally, we are going to square the sum. So this is square of sum, and this is sum of squares. So I'm going to square the sum, SUM squared. So let me just say SUM to the power of 2. So how do I write it? Okay, so that simply means equal to, I'm going to say sum of squares like 48 squared. But before I do that, let me just write down so that you'll be able to understand what is happening. Alright, so basically we are trying to find sigma of x1. We are trying to find sigma of x1 squared. We are trying to find sigma of x2 and sigma of x2 squared, and we are trying to find sigma of x3 and sigma of x3 squared. And then we're also trying to find sigma of x1 all squared. So this is where we are now, sigma of x1 all squared. This we've gotten, So in this case, you're trying to find sigma of x2 just squared. So this sigma of x2, which is sum of squares, which is what we have here, a sum of squares, sorry, is what we are trying to square. So just square the whatever value you have there, x3 squared. Okay, fine. So here is simply saying equal to power, and we are summing this 48. So just click on it and just say to the power of 2, comma 2, and that gives us the square. So you can also copy it across, but in this case I'm not actually going to copy it. So I'm going to just say equal to power. I'm going to choose this, and I'm going to say comma 2, that goes to the power of 2. And finally, I'm going to do it for this one, equal to this to the power of 2. Good, so that is what we have. So at this point, I'm going to just lay out all of this by putting the figures on them. So I'm going to say this is sigma x1. Sigma x1 is equal to 48. We have sigma x1 squared is equal to 2304, and sigma x1 squared, sigma x1 squared is equal to the sum of squares, 322. So you can do the same thing for all of them. Now we are now going to come to the important part, the formula for SST, SSB, and SSW. So we are trying to now calculate SST, sum of squares total, or the total sum of squares. I'm going to use another color this time. So SST is given by sigma x1 squared plus sigma x2 squared plus sigma x3 squared minus, now we are saying sigma x1 plus sigma x2 plus sigma x3 squared all over n. So keep this formula in mind. You need to just know about this formula. So if we put in all the values, now we are going to go back to try to use Excel to solve this. So instead of doing it manually, so I'm simply going to come here. So let me shift this a little bit upwards. Perfect. So I'm going to come here. So I'm now going to say, or maybe I'll just put in the values there. So have equal to sigma x1 squared is a sum of squares. Sum of squares. So we have sum of squares, which is 322 plus 148 plus 125 minus 48 plus 32 plus 27. So I'm sure you know where we are getting these values. We're going to say squared. The number of items there is 24 because we have 8 items each, so we have over 24. So I'm going to show you how to get this, to calculate this right now. So I'm going to shift this in a little bit upwards, and now I'm going to write SST here, and I'm going to put in the formula equal to, I'm simply going to use brackets, this plus this 148 plus. So it's interesting that it leaves a trail of all the items you are using in the formula. So we have minus, sorry, yeah, I think we're on track. So minus, we have this plus this plus this, that becomes squared. So have, but in this case now we are going to say power. Now to avoid this thing being too complex, I'm simply going to use this as, so now this 965 represents this item here. So let me say this. Now I'm going to calculate for this. So I'm going to say equal to, we have 48, which is this, plus 32 plus 27. Okay, so this represents these items. So at this point, I'm now going to square this and divide it by n. So I'm going to say equal to power, so power of L, so L9, we want to square this, so which is L9. So I'm going to say equal to power of L9 to the power of 2. All right, so now this item here represents the square of this sum here. So it means that SST will now be this minus this over n. So let's try, equal to this minus this over n, which is 24. Yeah. So we now have 118, right? Good. So let's do the same thing for, this is how to calculate SST. So I'm going to show you how to calculate SSB. So the key thing is for you to know this formula. So now I'm going to calculate XSB. So SSB is given by, this time we are saying sigma x1 squared over n1 plus sigma x2 squared over n2 plus sigma x3 squared over n3, and that will be minus sigma x1 plus sigma x2 plus sigma x3 squared over n. Now this number on the right hand side, this we already calculated it, so it will kind of be easier for us. So let's proceed at this point. So sigma x1 squared, so it is sum is this sum squared, right? So that is what we call it, sum squared. I couldn't write a squared, so I call it sum 2. So that gives us 2 3 0 4 over 8 plus 1024 over 8 plus the next one is 729 over 8, 729 over 8 minus whatever we have here. So I'm just going to, okay, let me just write it so that you'll be able to follow. Plus 32 plus 27 squared over 24. So again, let's go to try to calculate it in this place. Now we're trying to calculate SSB, right? So sum of squares between. So I have this over 8 plus this over 8 plus this over 8. So I have equals. In this case, I'll simply say equals brackets this over 8, right? Plus this, permit me to put everything in bracket, plus this over 8 plus this over 8. All right. So I think, okay, anyway, it's fine, but I'll prefer putting everything in bracket, so I'm going to just put this in bracket as well. So now we have the first part, which is this part. So I'm going to now say SST, it will be equal to this item, this 571, minus minus this, no. So it's going to be equal to 571 minus brackets this over 24. So minus this divided by 24, and that is going to give us 30.8. So I'm going to highlight SSB and SST as well. So this is SST, perfect. So now we can calculate SSW equal to SST minus SSB. So and that is going to be equal to 118 minus 30.8. Right? So that will give us 87.2. So SSW is 87.2. Alright, so now we have, let me just shift it here so that it makes some sense. Okay, good. So SSW. So now we now go to actually calculate. We now go to actually calculate the ANOVA statistics, right? So that statistics is called F. What's happening? Okay, fine, it's okay. So that is given by, I'm going to show you the formula in this side. So I'm going to try to use another color of pen. Let me use pink. So F is given by SSB over SSE times n minus m all over m minus 1. So in this case, n is equal to 24, m is equal to 3. So n is the total number of items and m is the number of groups. In this case, we have 3 groups. Okay, so let's shift up a little bit. Okay, so that's going to give us equal to SSB is 30.8 over SSE is equal to, so we have SS, this is SS, what? This is SSB. So, alright, so we calculate SS total, we calculate SSB. So I think I mixed it up. Alright, so divided by SSB over SSE, or SSB over SSW, right? So let's not confuse matters. This is SSW. Remember, SSE is the same as SSW. So that will give us 87.2 times 24 minus 3 all over 3 minus 1. So this is actually 87.2. Alright, so that is going to give us, if I work it out here, so it's, this time I'm calculating F. F is going to be equal to brackets 30.8 equal to brackets 30.8 divided by 87.2. We are now multiplying by times n minus m, 21, that is 24 minus 3 is 21, 21 divided by m minus 1 is 3 minus 1, which is 2. Alright. So we now have f to be 3.662. So this f is called f, f statistic, or we call it f absolute value of x. Now we are going to look up the critical value of f. Let's call it f k. Now we are going to look it up from the table. Now the rule is that if the f that is calculated is more than the f we get from table, is f more than the f crit, let's call it f crit, ABS. So if f absolute is greater than the f critical, then we reject the null hypothesis. If f critical is less than the f absolute, or if f absolute is less than the f critical, then we fail to reject the null hypothesis. Statistical table, I can't see. Let me see if I can get it. I used to have it open, but I can't remember why I just closed it. Statistical table. Statistical table. Because that is how I normally find it. So okay, so I'm going to just do this. So this is testing. Okay, so I don't find it. So, but I'm going to actually search a little deeper inside. So let me see if I can get it from here. Just give a second. Okay, so statistical table, I found the link. So this is the link. Okay, so now we are going to check in this statistical table. We are going to check for f value for ANOVA test. So let's look for ANOVA. We see that. So scroll down because this is important. So ANOVA, let's scroll down. So it's like we are out of luck. Okay, so now we don't have this here. So let me search again and see if I can find it. ANOVA table. Okay, so ANOVA table. Let me check if I can find it here. So ANOVA table. So this is a situation. Anyway, let me not spend all the time. So I'm going to just go back. So what we have actually as the value of F critical is 3.4668. Okay, so we have F critical to be 3.4668, 3.467. So in this case, we have absolute value of X is greater than the critical value of X. Therefore, we reject the null hypothesis and we can conclude that the values or the groups are actually different. Their means are significantly different. So we then reject the null hypothesis. So in another video, I'm going to try to explain to you. How to actually use the statistical table to look up the critical values. So I'm actually going to stop here. I'd like to thank you for viewing. If you have any challenges, let me know in the comment box below. And feel free to subscribe to my channel and share this video around with your friends.